Okay, I want to talk about some special properties of the first class lever. So, what is important for you guys to see in this is, like I had said before, the fulcrum does not have to always be dead center, but what we do need is the fulcrum to be between the resistance and effort forces. So you can see that that's true in all of these cases, but notice in this first example, we have the effort force and resistance force. It's equidistant. They're the same distant. And so the mechanical advantage in this situation is going to be 1 because your effort distance is going to be equal to your resistance distance. So theoretically, as long as there's no friction, this would be perfectly balanced, equal amount of effort and resistance force to balance it. Now, if we look at this example, notice we're applying the effort force closer to the fulcrum than we are the resistance force. Now, which of these examples, our second class or our third class, is going to be more like that? And which of these is the effort force closest to the fulcrum? So that is actually like our third class. So we have a situation where we still have, maybe kind of like these tweezers. Well, the effort force is too far away in this one. I would need my effort force to be applied like right over here or something. Do I have another tool? I don't know. I don't really have a tool that works like that one. So I actually, don't have a good example of that one. But what we need to know is that would act if our effort force is closer to the effort or closer to the fulcrum, our mechanical advantage would be less than 1. So this is more forces needed to get a smaller output. And then in our final example here, this is where the resistance is closer to the fulcrum, but the fulcrum is still in between. So that's going to be more like this situation. The resistance is closer to the fulcrum, but it's, in this case, in a second class, it's on one side rather than in between them. So let's go ahead and add in your notes here these 3 examples. So our first, let's see, that's 5. So I'll put my fulcrum right here in the center. We have effort force and resistance force. And then if you guys would also note in here, use a different color, MA is equal to 1. Okay? And then in our next example, we're going to put I'm going to keep them in order of first, second, third, or like second and then third similarities. So this one is the one that I'm going to put next, with the resistance force being closer, because this one acts more like a second class. So I'm going to list this one next here. And we're going to put the fulcrum at one end. Here's FR. Here is FE. And then this one is similar to second class. And make sure that you label that MA is greater than 1 in this situation. And then you'll put a line here to help separate them. And then finally we've got the example where I'll put my fulcrum on this end just so that I can keep the order of FE, FR, FE, FR. They've got them flip-flopped in the example in this slideshow. And so I'm going to put Fe and then Fr. So this is mechanical advantage is less than 1, and that is similar to a third class lever. Okay.